Hello, everyone, and welcome to the webinar. This is Sydney speaking, and today's webinar, as you all know, is on getting the most out of HSS. And what I'll be showing you today in HSS is actually we'll be going through some of the options over there, and we'll show you exactly different ways to use HSS in ways you may not have even thought that you could even use HSS. And some of the parameters also inside HSS as well, they can help you actually work with HSS even better than you've been working with it up until now. As usual, there will be time for questions at the end. And if you do have any questions, all you have to do is where you have the raise hand button, just click on the raise hand button. And in the question area, just write down your question. And don't forget, when you finish writing down your question, click on the send button as shown. This way I'll be able to see the questions at the end, so I'll know to answer them as well. Okay, so let's get down to this webinar itself. And let's first start with this part over here. Now, I'm not going to do all the operations yet on this part. I just want to show you some options on this particular part right now. And one of the things I'd like to start out is showing you the option of linear, and also stressing the issue of surface quality when using linear. Now, in this particular case, I'm going to demonstrate it on this surface around over here, these surfaces around this part over here. And note that you have some straight areas, shallow areas. This area over here is partly shallow over here, a little steeper over there. And what normally happens when using the linear option is that we all know that linear works very well in shallow areas, on shallow surfaces, okay? But when you have a steep surface, linear doesn't work as nicely. However, we can control it now to get a very good surface finish as well, even with linear, if you use a ball and mill. Now, I'll just give you a little example on this area itself. I'll start a new HSS operation, and I'll use the option of parallel cuts, linear, as shown over here. My geometry in this particular case, I'll choose it by clicking on the surfaces that I need to work on, and I'll just go around the part itself. And as you can see, just click on each surface that I want to choose. That one over there, going around the part, and until I finish this as well. By the way, this is being recorded, and the parts will be available on our site as usual. Okay, so I've picked the surfaces I need to work on. I'll accept that. And if I just want to make sure that I actually did pick the correct surfaces, I can always click on show and see that those are the surfaces that I want to work on at this moment. Okay, now I'll be picking my tool. The tool that I'll be choosing will be a ball end mill. Now note, I actually have here two ball end mills, and I'll show you the reason why I have two of them in just a moment. But let's just first start with the 10mm ball end mill. And let's go down to our toolpath parameters. Note, when we have our step over, we have what we call maximum step over. Not regular step over, but maximum step over. And when using a ball end mill, we also have the scallop. The scallop actually is what makes sure, is what actually controls our excuse me, the quality of our surface. If you take a look at this picture over here on the side, it actually controls the height of the scallops between each tool pass over there. So the smaller the scallop, the better the surface you get, and it does not make a difference what the angle, if it's a steep surface or a shallow surface, it'll keep that scallop height over there. Now note, right now I have a maximum step over of 1 and a 0.2 scallop. If I were to change my tool, say to a 6mm ball end mill, which is a smaller end mill, you'll note that when I go to my toolpath parameters, I have my maximum step over, and my scallop over here is actually smaller than it was before. Okay? Now, if I want to have a scallop or better surface, I can put a scallop of 0.01. Then you'll see my maximum step over will change as shown over there. Let me just leave it now at 1 for a moment, so we'll be able to see it a lot easier on our part later on as I do the toolpath. And I'm going to do calculate, but before I go into calculate, let me also just go into my link for a moment. And since I do have a large gap on this part over here, I'm going to go into my links and say in my large gaps, go directly from one area to the next. Now, one other thing also in my geometry, I skipped that for a moment, we also have the define angle. Now, normally it works on 0 degrees, but I can, which is along the x-axis, but I can also do it according to a specific angle. I'll put it at 90 degrees, so it works in my in my y-axis, going back and forth this way. Okay, let's just do a simple. One more thing in my links, I almost forgot. My large moves and the slices at the end, I'll just have it blend at the very end as shown over here. All right, let's run our calculation and then we'll simulate the part. You'll note, and I'll do this a little slow over here, it goes back and forth on the part itself, linear exactly the way I want it. You can see now the direct going on the other side. Now let's finish this towards the very end, and we'll take a look at the actual surface finish. If you see the way it looks right now, this actually looks a lot closer, the steps, to one another, and this flat surface also looks closer than it is over here. But if I were to zoom in to the actual toolpath itself and try to be normal to that particular surface, you can see as I'm going around the part, and now I'm normal to this surface over here, you'll see it's actually very even as it's going around the part itself. Now I'm going to be normal to this area. You see that the step overs are actually even on the surface itself, giving you a nice smooth surface finish according to the scallop. And this is possible, this is made possible if you use a ball and mill on surfaces such as these. Okay, now, while I'm here already, let me talk a little bit about this area. I want to make a little bit of a change. Now, you note that it went directly from one side to the next over here. Now, instead of doing that, what I'd like it to do before it goes to directly to the next side, when it relieves this surface, I'd like it to actually leave with an arc going up, and then go across to the other side, and then lead in with a arc going down into that area over there, instead of going directly into that surface. So what I'm going to do is, in my link between the gaps, we're going directly, that's no problem with that, but I'm also going to add the option of, instead of don't use lead in, out, I'm going to use lead in, out. Now, to define my lead in, out, I'll just go into this area over here, defining my lead in and lead out. It can use the default sets, or I can open it up, and I don't want to use tangent arc. I want to use vertical tangent arc, going from the top down into the part. And the same thing for my lead out as well. Now, one more thing also, in my arc diameter, my arc sweep, I don't need it to go a complete 90 degrees up. I'm just going to have it go at up until 40 degrees. Now, let's accept that and take a look at the toolpath now. You'll see that the toolpath, as it goes back and forth, there we go, let me stop it right now. You'll see that as it gets to the very end over there towards the gap, and let me zoom in over here, you can see the arc going up from the part itself and then going directly across to the other side. Now, one other thing I like to do over here as well, let me continue this as we're going around on the part itself. You can see that happening, but also note the feed. The feed is basically staying at 1,000, even though it's going in this area over here. Now, let's say this area over here is completely empty. There's nothing over here. In other words, right now, I'm going at a feed rate in an area where I really don't need it. I like to actually go my rapid move over here. Why not? So let me actually make a little bit of a change. What I'm going to do is, instead of large gaps direct, I'll change this to, let's go up to the safety distance and then do a rapid move. Now, one more thing also is, in my levels, I'm going to change my retract distance to 2 millimeters as well. Let's run my simulation after I calculate. And let's also now pay attention to my feed rate as it goes over here. Okay, in the beginning it's starting back and forth over there. Now as it gets to this area over here, let's see what happens. You can see the tool going over there. Note the feed 1,000. Now it's going to arc up off the part itself, go up, and now look what happens when it goes across. It's running at my rapid feed rate. Now, when it goes back down into the part itself with my lead in feed rate. Now it goes back to 1,000, going back around the part over there itself, leaving out the part, and back and forth it went to 6,000. Now let's go back and forth, and you'll see it jumping up to 6,000 as it goes, 60,000 as it goes back and forth over the part. And you can see that over the entire part, it just goes up and goes to its rapid feed above that area over there. And that's how we can also speed up the tool pass as we're going across the part. Okay, now I'm going to get back to this part a little later on, but I'd like to open up now a different part. Let me close this part over here. And we're going to open up my next part over here. And on this part, I'm going to do two different operations. Okay, now, the first thing I like to do is work on these three surfaces over here. Now, the way I'm going to work on it is, you know what? I'm going to work on the surface using the option of morphed between surfaces. Let's see how I can work with that. Again, I'm going to use HSS. I'm going to use the option of morph between two adjacent surfaces, where my drive surfaces are this one, and that one. My start edge surface will be the top surface over here. That's the surface where the edge of that is touching this surface over here. And my end edge surface will be this one over here, where the edge over here is touching that surface. Very easily chosen. Now my tool, again, I'm going to use that ball end mill. And again, note, in my toolpath parameters, we have again a maximum step over because we're using a ball and mill. Okay. Now, one other thing though, however, my toolpath, in this particular case, I'd like it to actually, instead of just stepping down each time, I'd actually like it to spiral on down. So as it's taking its maximum step over of 1, I also want it to go down at the same time. So if I go into my sorting, I can use my cutting method. Instead of one way, I can use spiral. Okay, let's take a look for a moment at the toolpath that we received over here as it calculates the toolpath itself. We'll take a look at the toolpath now, and we'll do this slowly. You'll note the tool goes down. It's going around the part, but note it's spiraling on the part itself. There is no, you can see that it actually has from its first tool pass, and then it slowly works away and then spirals down on the part itself. So it's one continuous toolpath. Now let me stop this for a moment. You'll note that the toolpath that it's working right now, it's working conventional. Okay? Let me stop this. To change the direction over here, all I have to do is direction of machining instead of conventional, climb. We'll recalculate the part of the toolpath itself. Run my simulation, and this time you can see it's going in the opposite direction, working climb milling on the part itself. And note, it's one continuous toolpath because I used the option of spiral. Let me go now towards the very end, and it went down exactly up into where I wanted it to go down. Now, the next what I'd like to do on this part is I'd like to show one of the options. I like to actually machine these surfaces over here. Now remember, I'm just using this part to show you different options in HSS. And I'd like to work on these surfaces over here. So for this particular case, I'm going to use the option of HSS with, excuse me, parallel cuts, constant Z. The geometry that I'll be using is I'll pick the surfaces that I want to work on. This one over there, that one, turn the part around, that one over there, this surface over here, this one, and this one as well. I've picked all the surfaces I want to work on, no problem. Okay. My tool I'm going to use, that same ball and mill. Okay. Again, we have our levels, toolpath parameters, maximum step down. I'll leave it at 1 millimeter right now. Let me just do a quick save and calculate. Now, I know, by the way, I know there are gaps over here between this. But let me just first do a save and calculate, and we'll see the result that we have over here. You'll note the result is what I expected it to be. Since we have gaps over here, it jumped up to the next surface, to its clearance area, and then went to the next surface, and the same thing in between each one of them. Now, to fix that, usually what people go is they go into link, and then they'll go into links, and then do either direct or fool around with these options over here. I'd like to actually do something else. Instead of using my links, I'm going to go into my toolpath parameters, and in my sortings, instead of using the option of machine by lanes is actually, it has its toolpath that it has to go around, and if there's a break, it just continues on to the next, directly to the next surface, according to the way I made my link between the surfaces. Now, if I want, I can use, instead of lanes, regions. Where in regions, it machines each region individually. Let's take a look exactly what happens over here now. What's going to happen is very simple. It's going to work on each region and then go to the next area. Okay? So this is actually a much better way to work in this particular case. Just by working by regions is a good way also to change the actual toolpath itself from jumping up every single time. It does each surface and then moves on to the next surface. Okay. Now, let me load my next part. The next part that I'm going to do is we're going to actually show how we can use gouge control to actually give us a better toolpath. Not just for checking for gouging, but this time I can actually use the gouge control for making my toolpath. Now, I'd like to use a linear toolpath now. A good way to show this is by, in this particular case, is I'd like to use a linear toolpath going on top of this part over here. Okay. So I'm going to choose a new operation of HSS, and I'll choose the option of linear cut as shown over here. My geometry in this particular case will be this face over here as shown. Sorry, not that one, my mistake. I'll choose, here we go, that face over there. I already picked the geometry before, so don't have to pick it again. You can see that's the surface I want to machine. My tool, again, I'll be using that 6mm ball and mill. And in my geometry, by the way, let me have my definition of angle set at 45 degrees. We have our toolpath parameters. I'm going to leave it exactly the way it is. And in my links, I'm just going to have my links at the very end to go blend splines at the very end. Okay, now let's run my calculation on the part itself. And let's take a look at what happens with this toolpath. I'm working on top over here, but note that since we have sharp corners over here, the toolpath in HSS and surface machining acts very strangely when it gets into sharp corners. If we take a look at the toolpath, okay, it starts out actually normal, going back and forth on that surface, but look what happens when it gets to those corners over there. You'll see it happening in a moment. You can see the following. It's actually doing something like this. It's going to the corners, then turns itself around in the material itself to go around that surface over there. Well, actually, let's actually hide the part itself. Let me just go over here and hide the actual component itself. If we take a look at the toolpath, you'll note if I look at the bottom, it's actually gouging into the material itself at the very bottom over there. Okay? That's because when it gets to the sharp corners, it has to go to the sharp corner and then turn its way around. Now, I can start fooling around with it by using, adding corners in my toolpath parameters, by modifying maybe the rounded corners. But you know what? Let's try something else. Instead of doing that, I'm going to change my geometry. My geometry, instead of having the face on top, face one over there, let me actually bring back my part so I can see it. Sorry. Unsuppress. I suppressed it by accident. And I'll do a show component. There we go. There we go. Now that I can see my component, what I'm going to do, instead of choosing these faces over there, I'm going to create a different geometry. My geometry that I'm going to create, strangely as it seems, is actually going to be the bottom of the part itself. It's a flat surface. Now note, if I do show direction, you see it's actually showing it that the direction's coming from the bottom. I actually want to have it coming from the top, so I'm just going to right click over here and reverse my direction. Okay, in other words, right now, if I were to machine it the way it is, my tool is going to work on that surface. Now, this is a flat surface, so in this particular case, my tool path is going to be very, very straight, but it's going to be on that surface. Now, what I'm going to do is I'm going to use my gouge check to help actually make my toolpath go on this surface itself, but according to the toolpath of that flat surface that I did over there. Okay, let's see exactly what I'm going to do. I'm going to enable my gouge check over here. This time, I'm going to go into the check surface is going to be that over there. That's going to be my check surface. Now, what do I want it to do when it actually hits those areas, when it sees that? Well, I want the tool to retract. Okay, that's fine. But I want it to go along the surface. In other words, it's going to attract along that surface itself and stay normal to this surface itself. So the tool path is actually being controlled by the bottom surface, but it's only going to go up until here because the gouge check is not going to let it go further down. Well, the result of that is actually very, very nice. It's not gonna, since it doesn't have to deal now with creating a toolpath according to these sharp corners over here. It's creating it according to the actual the surface at the very bottom. What's going to happen is very simple. Let's take a look at the actual toolpath itself. You can see it's going back and forth, but this time you'll note that it's going directly up and around the part without going into the area over there. If I were to actually just click on the part and hide my component for a moment, you can see that the very bottom of the part, there's nothing gouging now into the part itself. You can see we have a really nice toolpath on the part itself. Okay, this can be used in many instances, but this is actually a good case to show how we can use those areas over there. Okay, now let me just bring this back so we can see the actual part itself, show component, and there's the component itself. Okay, now I'd like, well, so what we saw here actually is how we can use gouge control to actually improve our toolpath. Now, let's choose a different part. And this time, in this part that I'm going to open, we're going to show how we can use roughing inside HSS. Okay, now what I'd like to do is actually mill down on this area over here around this wall, but we have excess material around there. What happens if we have excess material around the wall? Well, what I'm going to do is as follows. I want my toolpath to actually just go projected according to this curve, to work exactly on this curve itself around the part. So if I were to go into the operation that I've created over here, excuse me for a moment. I have to drink something here for a moment. My throat's a little dry, so you'll excuse me. Okay. So what we have here is as follows. We have here our geometry. My geometry, I'm using, by the way, projected user defined, where my drive surface is as shown over here, the bottom over here, and my projection curve is this curve around over here itself. Now, the way it is right now, I'll be using a 10 millimeter ball and mill, and what's going to happen right now is as follows. My toolpath is going to go down on that surface itself, around the surface. Now, what I said, however, is that I have a lot of excess material over here. I don't want it to go directly down over there. So what I'm going to do, instead of just doing a plain old toolpath on that, I'm going to go down into the option of roughing and more. Now, first let me go into my multi-passes. In my multi-passes, if I were to activate it, I'm going to use 3 roughing passes. Okay, so it's going to actually work 3 times in the pass itself, doing multiple passes going from the outside in over here. And the spacing in between each one of those passes is going to be 1 millimeter. Now, one other thing also, by the way, is that I'm using this on these 3 studs over here, which are equally spaced. So I've used over here also the transformation option over here itself, whereas in the transformation, I have a number of X copies is 1, but number of Y copies is 3 times, and spaced 80 millimeters. That's the space between each one of those. Okay. Let's run my calculation and simulate the toolpath itself. You'll see that the toolpath is going around 3 times in on the part itself. Now, now you see it also going on the next part because of that transform. Now, I'd still, however, like to do this several times going from the top down also as well. So instead of only multi-passes, I'll also add to that depth cuts. In my depth cuts, I'm going to do the following. I'm going to open it up and I'm going to say, okay, for I want to do a total of 10 cuts from the top going down, spacing them 5 millimeters in between each step down. Now let's take a look at the toolpath after I calculate it. Now, the finish allowance, by the way, in the depth cut itself or in the multi as well, we have here finished passes as well. The finished if I want to get closer, what this does is as follows. If I were to set this, let's say the last 2 steps after it does my 10 millimeters over here and spacing of 5 millimeters, I can say I want you to do 2 more steps as well, and that's going to be spaced 0.2 millimeters as well between each other. We'll take a look at the tool pass as it goes down. And let's take a look at the following. First, it's going to start off going down the steps from the top down. Now, let's take a look at the side view for a moment. And we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I didn't stop it, but let me take a look over here. We can see that as well over here. Now, what happened here is very simple. We have our 10 steps, but note, after my 10th step, I'd still have 2 more steps that were, as I said, 0.2 millimeters apart from each other. Now, if I don't want to go to the very end, of course, I have in my geometry drive surface offset if I don't want to go to the very end yet. Okay, so let's take a look now at the entire tool pass, what we have. And you can see the following. Going down with my 0.2 at the very end over there, 2 extra steps over there. And then it does this for all of the steps going around the part, for all of the parts going around. This one as well as this one, transforming over to the last one over there as well. Okay. Now, what I'd like to do is open one more part. Now, in this next part that I'm going to open, it's actually the actual first part that I did before. However, over here, what we're going to do is we're going to see how we can completely machine this part using mostly HSS. Now, you'll see that the stock in this particular case, sorry, just a moment. I don't have to do that. Right click over here. This is my actual stock over here. It's the shape around the part itself going all the way to the top. That's the stock I have in this particular case. Now, first thing I want to do is take out most of my material. Take basically all of my roughing material out. Now, for that, I'm not going to use HSS. What I'm going to do for that is use what we have, iMachining 3D. 3D roughing using iMachining. This is probably the quickest and most efficient way to work when clearing out all of the bulk of the material around the part itself. So we're using iMachining operation of 3D surfacing, and note we have our target here that's put there automatically. I'm using a 12 millimeter ML, and note I also have a holder over here. Now I want you to note also when using this holder, I've used the option in iMachining 3D of holder collision detection. In other words, it's going to make sure that my holder does not touch any part of my part itself, any of the material. And this is important in this particular case because I'm actually going pretty deep into the pocket over here. And we have a steep wall over here. I just want to make sure that my holder does not touch any part of the wall. And my tool path will actually be deflected so it does not touch any of those walls itself where it goes pretty deep into the part itself. And we'll see that later on in our simulation. Now my levels is going down my entire part over there. You'll note in my technology wizard, it has 8 step downs itself. Okay, and at the very end, it has 4 more shallow step downs over here itself. Now also note, in my technology, we have our rest rough over there. With the rest rough, it actually scallops its way up the part itself, as shown over here. Now the reason why the scalloping, because in shallow areas, I don't need big step ups, whereas in steep areas, we need smaller steps, whereas in steep areas, we need larger steps as we're going up. You'll see this actually happen as we do this simulation. Let's take a look at the actual simulation itself. Well, it's going to recalculate the toolpath. I made a little bit of a change over there, which gives me a good chance to actually drink something. Let it finish calculating the toolpath itself. Okay. Let it go. Don't worry, it's calculating. Now, as it's calculating, let's just look over some of the questions. Okay, I think as far as roughing and more, how do we set the finishing allowance? I think I showed that. Okay, let the calculation finish. It'll take a couple of moments because this is actually a pretty large part. I'll be very honest with you. I didn't want to recalculate. I did it by accident. I just wanted to go out and just run the simulation. But okay, let it recalculate. No problem. It'll run very quickly in a moment or two. And let me also just mention that as it's recalculating, you'll note that later on I'm actually going to start working finishing operations over here itself. Now these finishing operations that I'm going to be doing over here, I'm actually going to be using HSS instead of HSM. Now the reason for that is very simple. I want to be able to show you that I can actually have very good surface control of each surface of these surfaces over here by using HSS, having it work in exactly the shape that I want it to work on those surfaces over there. Okay, let it finish doing the calculation. By the way, as usual, the webinars will be available on our website. This is being recorded, and the parts will be available for download as well. Okay, the calculation is still going on, but as you see, it's going further and further down. Now, the advantages, however, of using iMachining 3D is the fact that it takes those it uses the actual iMachining toolpath to get those feeds and the spin rates and feed rates really up there to really high speed rates, and also deep cuts, making it also very efficient toolpath without any vibrations of the part, also removing your material very, very quickly on the part itself. Okay, we're almost done with the calculation. Okay, we'll wait another moment. Okay, by the way, if there are any more questions, you can also write them down. I will try to answer them. And we're almost done. Okay. Okay, now just going through the rest cuts. This will go a lot quicker. And by the way, while I'm still calculating over here, let me just show you also, we have our webinars over here on our site. Webinar recordings. And just like any other webinar I've done before, you can go into them and you'll be able to actually also download the video, watch the video, and download the parts that we used in the webinar itself. Okay. Now it's just generating the actual toolpath around the part itself, just the toolpath preview. It's actually finished calculating. If we take a look now at the toolpath itself, and I'm going to use quick solid verify to show the toolpath itself. You can see the toolpath working on around the part itself with the holder. Now I want you to note what happens when it goes inside these areas, inside those pockets over there. Now you can see the rest rough as it's going up the part itself. Take first that larger step, and then it steps up on the part itself. You can see the step ups over there. Okay? As it's going down. Now I want you to take a look, as I said, inside these pockets over here, because inside these deeper pockets, we have the holder to take into consideration. Now look what happens in this area as it gets closer to this area or these walls over there. The toolpath is actually being changed to go further away as not to gouge the part itself. Okay? That's what I had mentioned before, by the way, in the tool where we have our holder collision. Now let's continue down on the part itself. And I see there's a question over here. I'm going to answer this right away. Would I prefer iMachining 3D instead of HSR? Where I can, definitely I personally would prefer it because it works a lot quicker. Okay, when I can use it, I prefer using it. Okay. Now, HSS. What did I do over here? Very simple. The first thing I wanted to do was work on these surfaces around the part over there. So what I'm going to do on this particular, what I've done in this particular operation is very simple. Parallel cuts linear. My geometry in this particular case were those surfaces over there, and my defined angle was 90 degrees. Taking a look, let's actually just use now HostCAD to take a look at the simulation. Taking a look at the simulation itself, you see the toolpath goes back and forth on those surfaces over there. Very simple. Now, the next operation that I did over here was for working on these arcs over on the actual fillets over here. I wanted to work on these fillets as shown over there. So for that, I've used the option of morph between two boundary curves, where my geometry, my surfaces, was the actual fillet around those edges over there. And this is, by the way, one of the most popular uses that I've seen used for cleaning off these type of fillets, even on 2.5D parts, regular 2.5D parts as well. Okay, where my start edge is that first edge over there, and my end edge is the bottom one over there. So it's actually going to take the shape of that fillet going around over there. I'm using a ball end mill, and of course we have our toolpath parameters, whatever value I have over here, 0.2 in this particular case, and my sorting was kept at 1 way. Okay, taking a look at the actual simulation itself, you'll see that the toolpath goes around and around that part, machining exactly the way I wanted it to machine that part. Really good, efficient toolpath for those particular surfaces over there. Now, I'd like to continue actually down now on these walls over there, also using morph between two curves. However, if you remember that this wall over here and this wall over here had excess, these areas actually had excess material going down in those bottom areas over there. So what I've done is I first used a constant parallel cuts constant Z on these surfaces over here. Okay, only on those surfaces. And what I did was also the following. I limited the area of operation. I don't have to work, I don't want to work on this entire area over here, just between certain areas itself. A Z level of -40 and down towards the bottom. Now what I did was over here also is I did a drive surface offset, not to go all the way to finish the part itself, just to cut from this excess material on the outside. And since I don't, there was a lot of material left over there, I choose the option of multi-passes in that area itself. Now, let's take a look at the actual tool path that I have over there. And I'll use the option of, again, quick solid verify for that part itself. You'll see that I'm just working in that area itself. Let me actually zoom in a little better and run the simulation again. You can see that it clears off that area. Okay? If I take a look, by the way, in the host CAD, you can actually see the tool path as it works in several times going into the part itself. You can see the actual tool path is working its way in. Okay. Now, for my next operation, what I did was working, again, morph between two boundary curves, where my geometry, my surface that I want to work on is these surfaces around over here. And I wanted to take the shape between this area and this area, which is why I use the option of morphed between two boundary curves, where my first curve is the one on top over here, on top of that edge of those surfaces over there. And my end edge was at the very bottom over there. Now, again, I used a 6mm ball end mill. If I take a look at the simulation, you'll see the toolpath going around that part, and you'll also note that how it's slowly changing the shape from this towards this area over here. Okay, now what I did at the very end is I also wanted to do the same for this bottom surface over here, but this time this area I wanted to have the shape of this area itself as well. So what I did was over here is I did the exact same thing I did before, using morph between two boundary curves. This time my surface was these edges at the very bottom. Of course, it's around the entire part as shown over here. And this time my start edge was this edge over here, where my end edge was the bottom one over there. Again, using the exact same tool, taking a look at the simulation. This time it's working just on those arcs over there. Now, some people have asked me, if I did morph between curves on this area over here, this area over here, and this area, why did I break it up into 3 different areas? Well, the reason why I did it that way was very simple. It's because I wanted this area over here, this fillet, first to have its particular shape. So I had complete control of that particular shape. Then this area around here, I wanted it to take the shape of that area itself. And then the bottom, I wanted it to keep the shape of this bottom internal fillet over there. By doing it in 3 separate operations, I was able to control each area individually. Having that very first one over here, next one over here, and then continuing down to that area over there. Now, my next tool pass is actually working in this area itself. What I did was over here is very simple. I wanted to work in this area on this particular surface, going back and forth, up and down on this surface over there. So what I did was very simple. You'll note that's my tool path. Okay? If I go into the operation, I chose the option of perpendicular to curve, whereas my drive surface is that surface over there, and my lead curve is actually this bottom one over here. So the tool path is actually perpendicular to that particular curve, which is how I got this particular type of tool path. Now, another option I'd like to work with HSS is in this area over here. In this area, I like to machine this surface over here. Again, I've used the option of morph between 2 boundary curves. This, by the way, is a very popular option that's used. My geometry in this particular case was that surface over there. My start edge, this one going around over here, and my end edge on this side over here. Now I used a ball end mill of 8 millimeters with a 4 millimeter radius. That happens to be also, in this particular case, the radius of these arcs over here. So I actually can finish those areas over there as well by doing this operation. Run my simulation, and you can see that's actually going around that area, working inside over there. Now, one more operation I'd like to do is I'd like to work on these flat floors over here. This particular flat floor over there. Now, this floor is actually a constant Z floor. In other words, it's one flat floor. So what I'm going to do over here is I'm not going to use HSS. What I'm going to do here is a very simple operation. What I've done here actually is used HSM. And when I use the HSM, I use the option of horizontal machining. Horizontal machining automatically picks out every single flat floor area. Now, in this particular case, I used a 10 millimeter bull nose tool with a 1 millimeter radius in the corner. In other words, we have 8 millimeters flat on the bottom. And since I only wanted to work in this area, I gave a constraint boundary of that particular face over there, as shown over there. That's the face I used. I used the option of selected faces. Run my simulation. You'll see that the tool goes down into that area itself and just clears out that entire floor. Probably for flat floors, this was probably the easiest option to use. Okay? Now, if I really wanted, by the way, I could have done it on the entire part, and then it would have cleaned this flat floor over here as well as this flat floor over here. But I wanted this flat floor to continue on with this radius over here, therefore I didn't use it in this particular case. Okay. that's basically it. Now, of course, I can continue on with this part, but yeah, I just wanted you to show you how we can machine the entire part using a combination of many HSS operations that give you complete control of those surfaces. Okay, now let me just go. I see I have one more question over here. It says I usually use morph between faces more than morph between curves because normally there are less faces, which is you're absolutely correct. I could have used morph between faces. It was a matter of convenience for me at the time. It's true. Many people are more comfortable using morph between faces. When you can, use it. There's no reason why not to. Because in many cases, it'll actually save you from choosing several. A face sometimes can have several curves on it. Instead, so you can choose one face, which will automatically gives you those several curves in it. So you're absolutely right. You can definitely use this. It's a matter of convenience, which you are actually more convenient in that particular time. Okay. I'd like to thank everyone for joining the webinar. And again, we'll have another webinar next week. So have a great weekend. And this will be available on our website. Take care and have a great day.